If you have a dime, you could break it down into smaller units, like 2 nickels. You could then take your nickels and break them down further into 10 pennies. In chemistry, a compound, which is a substance made up of 2 or more different elements, is a lot like your dime. Compounds can be broken down into smaller units. Of course, compounds don't break down into nickels and pennies. Instead, they break down into either smaller compounds or their basic elements. Did you ever pop the cap off a soda bottle and witness the fizz? That is an example of a compound being broken down. A closed soda bottle contains the compound carbonic acid, or H2CO3. When you pop it open, the carbonic acid decomposes into water, H2O, and carbon dioxide, CO2, which provides the bubbles. Water and carbon dioxide are simpler compounds than carbonic acid, but they are still compounds. Therefore, they can break down themselves to leave us with the basic elements hydrogen, oxygen, and carbon. Compounds break down through chemical changes. Sometimes this chemical change requires energy in the form of heat or electricity. In this lesson, we'll look at how compounds are broken down using these energy sources. If you spend any time in a chemistry lab, you'll probably encounter a Bunsen burner, which is a gas burner that comes in handy when you're trying to create chemical changes. Heat is an energy source that can cause compounds to break down. This allows the compounds to split into smaller units. One example is the breakdown of mercuric oxide, which has the formula HgO. If you put this compound into a test tube and hold it over a lit Bunsen burner, it will decompose into the elements mercury and oxygen. In this example, we see the heat caused the compound to break into its basic elements. These elements are like the pennies we discussed earlier, meaning they cannot be broken down any further. However, heat does not always cause compounds to break all the way down to elements. Some compounds break down into simpler compounds. For example, when you add heat to sodium hydroxide, it breaks down into the simpler compounds sodium oxide and water. When you think of electricity, you probably think of it as the wonderful resource that allows you to run your computer and television. However, a chemist might look at electricity as a useful tool for breaking down compounds. A great example is the use of an electric current to break down water. You recall that water is a compound that has the chemical formula H2O. You can break this compound into its elements, hydrogen and oxygen, by using electrolysis. Electrolysis is a chemical change produced by sending an electric current through a compound. Electrolysis works because the hydrogen and oxygen ions are held together by an electric attraction. When the electric current is introduced, the attraction is broken. The funny thing is that when hydrogen and oxygen exist by themselves, they are highly flammable gases. Yet, join them back together, and they become the highly non-flammable compound water. This demonstrates how much elements and compounds can differ in their properties. Breaking down water to free up hydrogen is something that has piqued the interest of many green energy scientists. Because hydrogen has a lot of energy, it is being looked at as a possible source of fuel for things like your daily commute to work. Maybe someday, hydrogen will take over for the fossil fuels that most of us rely on today. Let's review. A compound is a substance made up of 2 or more different elements. Compounds can be broken down into smaller compounds or their basic elements by chemical change. Sometimes this chemical change requires energy in the form of heat or electricity. For example, heat can be used to break down mercuric oxide into the elements mercury and oxygen. Heat can also be used to break down sodium hydroxide into the simpler compounds sodium oxide and water. Electrolysis is the chemical change produced by sending an electric current through a compound. Using electrolysis, we can break down water into its elements, hydrogen and oxygen.